We last left off the previous video by creating these contour lines on our Rhino geometry. And basically what we've done is reproduce the Rhino command, but made it slightly more dynamic because we can adjust this slider to control the material thickness. Remember, this is all parametric, meaning that it's based off of the original geometry we gave it, so we could feed it a different geometry. But that also means we can go ahead and move this geometry around and all the contours will move with it. We're going to want to do that because what we're going to start to do is lay these contours out along the XY plane, and the first one's going to be at this origin. So we don't actually want the surface here at that location, because just visually it's going to confuse us a little bit and it's going to be kind of existing in the same place. So what I'm going to do is just go ahead and drag this so it's well off of the XY plane. And you'll see the actual contours move with it. These were the kind of boundary curves that we started off with that made it up. We don't need any of this geometry, so I'm going to just go ahead and select that and delete it. So now what we need to do is we want to lay all of these curves out in an order on the XY plane, because we can't laser cut them as is, because they would all intersect with one another. And they're also not organized or labeled or anything along that line. So we want to go ahead and do all that. And we're going to do it in the grasshopper definition, so it saves us time for manually working through there. The first thing we need to do is we're going to start a whole new paragraph. And remember, what we did in Grasshopper was we kind of equated this to writing a paper. This is all one paragraph because it has one kind of complete idea. The next idea is to create a series of points along the x-axis and then to move all of these geometries based on those points. Well, to start a new paragraph, we don't want to be wiring information down here because that can get really distracting. So what we're going to do is we're going to take that information and bring it down with one of these containers. Remember, I talked about the parameters being all sorts of inputs and containers. Now we've created a whole bunch of section curves. So you hover over here, you'll see curves. We want to use a geometry curve component. So we're going to go to Parameters, Geometry tab, and use the curve component. We're going to go ahead and wire those in. I'm actually going to call these my contour curves. See, notice how I'm leaving the word curve in there so I understand exactly what type of geometry it is. And now I can bring this down below, but you'll see I get this wire that's kind of just a little bit visually, it's not super great. And the other thing I mentioned was we never want to really work backwards. We're always working left to right. We don't want wires coming backwards because it's a really easy way to get us all confused. So to use this, what we're going to do is make this what's considered a wireless receiver. Just simply right click on the component, go to Wire Display and set for Hidden. Now when you click off of it, you'll notice you get this little Wi-Fi receiver. And when you click on it, you can still see where that wire is coming from. So it's a really good way to hide the wires when you don't want to see them, but then be able to click on them when you do want to see them. Now the same information that's happening up here is now been copied down here. So we don't need to see the old information anymore. So again, we're going to right click on the body of this component and deselect the preview so it goes dark gray. Now the only preview that's available for us is right here in this component. Now the first thing we want to do is we want to create a series of points along the x-axis. We want to space those out by at least how wide this is. And like I said, this is 12 inches by 12 inches. So we want all of those points to be spaced out along the x-axis at least by 12 units. So the first point will be 0, 0, 0. The second point will be 12, 0, 0. Then 24, 0, 0, 36, 0, 0, so on and so on. To create those points, we're going to go underneath our vector component. We're going to go to our point panel. We're going to construct a point. And there's our actual construct point. Now we're going to move this over a little bit because we're going to need a little room to work in here. And as I was mentioning, the first point 0, 0, 0, then it's 12, 0, 0, 24, 0, 0, 36, so on and so on. So right now this component's already gray. It's one of the few components you drop in that's gray and ready to go to start with. The reason is it already has values stored inside of this x, y, and z, and they're all 0, 0, and 0. You'll also notice at the origin there's a red x that's representing that. Y and z can stay 0 because we're doing this along the x-axis. So we don't want any values in the y or the z. But we do want to change or add more values to the x. Okay, so the first one being 0, 0 is great, but the second one now needs to be 12, 0, 0, and then 24. To do that, we need to start counting. And to count, we go to Sets, Sequence, and Series. We're going to put this over on the left. And the series is essentially a counter for us. It'll ask us where do we want to start counting. That's the S input. We want to start at 0. Perfect. The n is the actual step size. What increments do we want to count by? We don't want to count by ones. In this case, we want to count by 12s. So to put a value in there, we're going to use that panel tool again. So go to Parameters, Input, Panel. In this panel tool, we're going to enter the value of 12. Again, don't hit Enter, don't hit Spacebar, just 12. And we're going to wire that into the n input. Now we're counting by 12s. And the next line we want is, how many do we want to count for? Well, we want to count for every single one of the contour layers that exists. How many contour layers exists? Well, we could count here, but this is the contour curves. Some layers have more than one curve. But the other thing that represents the number of curves is the number of planes that we made here. So if I hover over this P output, you'll see in the top here it says 42 locally defined planes. We want to count the number of planes that exist, because if we can count the number of planes, one plane equals one level. That's how many layouts, levels that we need to lay out here. So to bring those planes down, we're going to go to Geometry, Parameters tab, Geometry. We're going to go ahead and find a plane component. There we go. Okay. And we're just going to label this as my planes. I'm going to actually even label these as XY planes. Again, we're going to make this a wireless receiver, so simply right-click, Wire Display, Hidden, and we're going to bring this down below. Now we can't wire this in directly, but what we need to do is count how many items exist in here. I can see it right here when I hover over it, it says 42, but the output is not the number 42, the output is planes. We want to count how many items exist in this component. To do that, we're going to go to Sets, List, we're going to use a list length component, and that measures the number of items, the number of data, amount of data in a component. Hover over there, and now the output is the actual number 42, because there's 42 different planes in there. Now we can go ahead and use that as our count, and you'll see on our series it starts counting. I'll use a panel tool to show you this. It starts counting at 0 and counts by 12. 0, 12, 24, 36, and it does that 42 different times. Those are going to be our x values, so we can wire those into my x. And you'll see now what we've got is a whole lot of points laid out on the x-axis. Perfect. These are going to be like, say, the lower left corner of all of our contours. So what we want to do is we want to take these contours and move them from wherever they exist right now to each of these points. Well, when we copy down these planes, we got a duplicate version of those. Let's go ahead and just select all this stuff and turn off the preview. It's important to understand in Grasshopper, you're never destroying old data. I can always go back to other information, like say the vertical edge that I started off with, right? Or all the edges, and use that. We're never destroying old data. We're always just copying new versions of that data. That's why there's no actual copy command, because there's no such thing as copying. Every operation is a copy in a way. We're never destroying old data. We're always adding to it. Okay, so now what we want to do is we want to move all of these contours to all of these locations. So to do that, we want to use a move component. Let's go to Transform, Euclidean, and a simple move. There we go. So the move is, the first question is, what is the geometry I want to move? I'm going to go ahead and move all of this contour information. And the next contour is the translation vector. By default, it's set for 0, 0, 10, meaning it's going to move at 10 units in the z-axis. We don't want it to move it by 10 units. What we want to do is we want to move the first layer from, say, this lower left corner to this first point, the second layer from the lower left to the point. So what we need to do is we need to find a common point on all of these layers. Well, guess what? Those are all the divide points that we used, okay? So we can use all 42 of these division points. Let's bring those down, go to Parameters, Geometry, and Point. And we're going to call these our base points. I'm going to call it points. Again, Wire Display, Hidden, and bring those down, okay? But we need a vector. Okay, these are simply points. A vector is a from a location to a location. To do that, go to your Vector tab, the Vector panel, and we want to generate a 2-point vector. There we go. We want to go from these base points to these newly created points in the XY. And you can't see vectors, right? So what we need to do is use a vector display. And you don't need to really do this. You can just watch me do it. Or actually, no, you should follow along and do this so you can make sure you did it properly. You go to display, go to vector, and use the very first vector display. Do not use the vector EX, use the very first vector display. Drop that component. The vector we want to display is the vector coming out of the 2 points. So wire the V into the V. And the anchor should be whatever is wired into your A input. So in this case, the base points is wired into my A input of my vector. I'm going to also wire that into the A input of there. And now you'll see what we actually did was we created all of these vectors that move from the first point in the original location to the first point of the laid out location. Second of the original, second laid out, so forth and so forth. So you can't use this to do anything. You'll see it's kind of like has a little sawtooth end, shard off end. You can't use those vectors to do anything. They're just visually there to make sure that you did what you wanted to. Since I see that's all correct, I'm going to go ahead and delete it. And I'm going to use this vector as my translation vector in the output. You notice in Grasshopper, hopefully you've learned this by now, you don't have to connect A's to A's, V's to V's, T's to T's, so on and so on. You just have to make sure what it's asking for, in this case a vector, is what you're giving it, in this case a vector. That's perfectly fine. Sometimes the labels are different, but you can go ahead and wire those in. Now you'll see when you did that, it doesn't quite work out the way you anticipated. Why? Well, because some of these curves have multiple, or some of these layers have multiple curves associated. That has to do with this wire type, and I don't want to get into exactly what that means because it's a little more complex, but we do want to have similar wire types within here. Okay, so what I want to do is I'm going to go ahead and I'm going to do an operation called grafting, meaning I'm going to make multiple vectors here. So to do that, I'm going to simply go underneath our sets, tree, and graph tree. And I'm just going to drop this in, run my vector through there, and then run that into my translation. Let's see what that looks like. Good, we got a whole lot of squares to start with, and then as we go on, we got a lot of different vectors that lay out. Perfect. These are each of those organizations. Now you'll see they actually overlap. Why? Because these points are spaced out exactly the same width as our object. What I might do is come back here and say, okay, instead of spacing that by 12 units, let's space it by 13. And that'll give us one extra unit and a little bit of space between each layer there. It's a little bit easier now to see the individual layers. I'm going to relabel this slider, by the way, by just simply right-clicking on it, going to the blank top here, and call this my my layer spacing. There. Okay. So now that controls our layout. So we don't need to see any of this. The only thing we're interested in is the final move geometry. So I'm going to go ahead and select everything else. Right click, preview off. There you go. Now all your layers that were once previously stacked up here are now laid out all along the x-axis for you, and you can see those. Then the final operation we're going to do, your next task should actually be to go ahead and fill in this panel tool the same way we wrote descriptive sentences about what we did here. Here you'd want to write something similar. So here what we're going to say is we created a series of numbers corresponding to our layout distance. We created points along the x-axis at those distances. We brought down the base points and generated a 2-point vector, and then moved the contour curves to the newly created x points or points along the x-axis. So you want to go ahead and write that in this little paragraph here. I'm not going to spend time doing that for you, but what I am going to do is I'm going to copy this down below because we're going to do one last step here, which is to label or tag all of these things. So I'm going to call this step 3. And I'm going to go ahead and say tag all contour curves. There. So I'm going to go ahead and, if you haven't yet, you want to hit save. One thing that's really important is that you need to save your Rhino geometry and your Grasshopper file, your Rhino file and your Grasshopper file. What I like to do is do a file, save as, and I'll name both these documents the same exact thing. So if this is Assignment 4 base surface, I'm going to call this Assignment 4 base surface. That way they'll show up next to each other in my folder, and I know to always open this Grasshopper file with this Rhino file. So if you haven't yet, go to File and Save. Make sure you save this. Also make sure that you've saved your Rhino file at this point. I'll see you for the next video.